Welcome, everyone, to the Polaris series of webinars. Today's presentation, Software Delivery in an Embedded World. Thank you for joining us, and we will commence shortly. We are very pleased to have with us a special guest presenter today, David Rosen, Ecosystems Manager at Electric Cloud. David is responsible for business development, strategic and tactical partnerships, and has over 12 years of experience in defining, implementing, and selling enterprise software. Electric Cloud delivers solutions that automate and accelerate the software delivery process. The company's award-winning products help develop organizations to speed to market, to boost developer productivity, and improve software quality while leveraging operational efficiencies provided by virtual cloud infrastructures with leading companies across a variety of industries. As well, from Polaris Software, we have Reg Struck, QA Product Manager. Reg is Polaris' expert on test management with over 20 years of commercial software development and testing experience. He is dedicated to the domain of test management. I will now turn the agenda over to Reg. Welcome, Reg.
To start with is I'll just go quickly through the agenda. I want to start with, for those who specifically from the Electric Cloud side might not know about Polaris, tell a little bit about our company. David will talk about continuous delivery, best practices, and then we'll actually talk about the integration planned with Electric Cloud in our ALM solution suite. And then, as Nancy mentioned, we'll do actually Q&A and attempt to answer all of your questions at the end of the webinar session. So Polaris, for those who do not know who we are, we're actually a commercial vendor, software vendor. We're located at corporate offices in Stuttgart, but we actually are a global company with our North American office in San Francisco. We are an ALM. Our platform is based on Subversion, and we're actually web agnostic, so we're a true web-based ALM solution provider. We can break out our product into four different distinct categories. Obviously, the entire suite, which is the ALM. And then we have our requirements that you can buy separately, as well as our full test management, Polaris QA, and then a full version as well. I'd like to introduce David Rosen from Electric Cloud, and he's here today to talk about, obviously, continuous delivery and all the encompasses with that. David, welcome.
Excited and very happy to be here today. So the topic of today's discussion is around software delivery, continuous delivery in the world of embedded development. So that's a new and emerging field and quite exciting. Lots of activity and lots of thinking going on how you actually optimize and get better at delivering software and delivering products in the context of embedded development. So this initial slide is just sort of setting the stage for this discussion and talking about some of the challenges and some of the changes that's currently occurring in embedded software development. So at the far left, this compression of release cycles that we're seeing, where it used to be release cycles of 5 to 7 to 8 years, now that's being pushed down to 12 to 24 months, if not faster. So just the demand in terms of how fast you can churn out new products is increasingly dramatically. In terms of complexity and size, we're seeing a dramatic growth in terms of how much code and how much complexity you have to deal with as a product developer today. So we have examples in the Electric Cloud customer base where we've had customers telling us that about code bases that have been very huge at sort of 70, 80 million lines of code about 4 or 5 years ago are now at 140, 150 million lines of code. So obviously that's a very extreme example, but we're seeing a dramatic growth in terms of code size and complexity across the board. Change frequency is obviously around the introduction of agile, meaning you're going from a daily build or a nightly build or a nightly change, a nightly integration, to a need to integrate and test your system and software up to hundreds of times per day. Variant management, as hardware is becoming commoditized, the number of sort of variants, the number of differences in terms of the matrix of your portfolio that you need to manage is also growing dramatically. And lastly, just the globalization of software and product development today presents a lot of challenges, not only on a geographical basis, but also on a systems basis. And how do you integrate and how do you get traceability and visibility across all of your different systems and processes? So all of these kind of challenges and realities present various potential bottlenecks and present various opportunities for improvement and where you can actually make a difference and differentiate in the market. So with that, I just wanted to sort of present one set of examples from one particular industry, and that is automotive. And as you know, and as you probably know, there is an explosion in terms of software that's currently going on in the automotive space. Not only in the infotainment area, where every car maker today is working on sort of getting the smartphone-like experience within the infotainment or an IVI system, there's also a growth of software in the actual traditional controls, where that's really how you differentiate and that's how you add more value into a car today. And with that, every car maker and every supplier in the car industry is becoming a software company, and they have to learn how to deal with complex software development. And obviously we've seen a number of examples in the last years around some of the problems and some of the flaws that actually come out of that, because car makers aren't that mature yet in terms of how to deal with a lot of the software. And just to be honest, just the complexity of these software systems is staggering at some point. So what are some of the approaches and takes on how to improve? I mentioned Agile, the introduction of Agile, and yes, that's been a trend. Agile has been around now for more than 10 years as a concept, and it's pretty much an established way of working. And we're definitely seeing growing adoption of Agile, even in the non-standard software environment. And really what it's all about, reduce the size of batches, reduce of smaller increments at a faster frequency, allows you to go faster. So again, it really started with Agile development, which led to an introduction of continuous integration and how you are constantly integrating your software and your products pretty much on every change. That is now, in recent years, since the introduction of this concept in 2010 by Jess Humble and Dave Farley when they wrote the book of Continuous Delivery, that is now really becoming sort of in concept, the conceptual replacement of Agile development today, where really continuous delivery is not only about reducing the size of your batch and sort of iterate at a higher frequency. Continuous delivery is really about the mantra and the mindset within the product development organization of having a constantly shippable product. At the end, at sort of the fixing and automating that last mile of shipping product is what we call continuous deployment today. And Kurt Bittner, a fairly well-known analyst at Forrester, made this a quite interesting quote some time ago, really around if Agile was the opening act to great performance, continuous delivery is the headliner, and we definitely agree on that from the perspective of electric cloud. So I threw out a few terms here, so let me just spend some time here setting that in context and making sure that the definitions are correct. So really I mentioned Agile as sort of an organizational way of working where you're iterating at a high frequency, smaller batches. Continuous delivery is sort of the next step in that, in terms of your product development organization is constantly at a state of shippable, of being ready to ship, basically taking away the complexity of shipping product. You're not shipping on every change. That's really what continuous deployment means. And sort of some terms within continuous delivery includes continuous testing, and Reg is able to talk a lot more about continuous testing. Lastly, continuous integration and how you're integrating on every code change. You're running an integrated build and you're running a defined set of tests just to make sure that you have the basic quality sets defined.
I'd just like to add that certainly I don't want to say that the other components of the process are not as important, but where continuous delivery can shine is definitely with continuous testing. And what we mean by this is that it's the concept and the methodology that you put in place for doing continuous code builds, then testing it, then deploying it, and then doing full circle within your releases, where or you're doing continuous delivery of those tested code. So what does that really mean? Well, the reality is that if you're doing continuous testing and it's successfully implemented into your continuous delivery methodology, you should be able to basically get defects faster, so being able to find defects faster and earlier, since your iterations are now being even more condensed in an agile environment, and then being able to actually, with each deployment, so even though it's not going out to the field, it's actually production-ready software code, you should have actually less defects that are actually in that overall production code. So that really is what the benefit of why we want to do continuous testing. And really, when you think about this, is that it's a 70-30 rule. So what we've seen in the field is that 70% is automation within the testing environment, and then 30% still remains manual testing. Thanks, David.
Thanks, Reg. So just the last term I wanted to sort of throw in on this slide is DevOps. That's a term that's becoming more and more mentioned. Perhaps not so much in the embedded space, but definitely so in the enterprise IT or web development. So to us and to me, DevOps makes a lot of sense in enterprise IT and web development, when you are actually not only the product developer who builds the product, but you also own the target environment. You own and manage and are responsible for the stability and the execution of where your product is running. So basically a website or an enterprise deployment of an application is definitely fitting that mark. In the context of embedded, DevOps to me doesn't really yet fit in that much, since once you've shipped a device or once you ship a product, an embedded product, you're not really, the end customer is the one that is typically managing that product. So you don't fully own, or you aren't responsible, or you have no control over the production or target environment. So DevOps in the context of embedded, I think it still needs some time to mature. I know quite a few people think of DevOps as also the R&D infrastructure or R&D operations. That to me is a different domain, but that is a fairly common way to think of DevOps in the context of embedded, for the team that is responsible for setting up and manage the R&D infrastructure. But I just wanted to make that distinction in terms of the way I view and look at the term DevOps. We talked about Agile, and we talked about sort of in the evolution of Agile into continuous delivery. So I just wanted to take the time to present some recent data, some recent market data from BDC. You can see here, this is from a report that came out a few months ago from BDC, where they had surveyed a fairly large number of embedded engineers, and really in terms of their viewing of adherence or adoption of Agile, roughly 50% is on the sort of right-hand scale here, right-hand side of the adherence, which I think is quite interesting. I was perhaps expecting a higher adoption rate, but clearly there is sort of a growing number of embedded engineers working in the context of Agile. And again, and we are definitely seeing in our discussions, in our interactions with customers and prospects in the embedded space, a curiosity and an interest in how can we take our Agile adoption to the next level. So in other words, how can we take our development methodology and transform that into a continuous delivery way of working. This is the second slide of data that I wanted to present from BDC, where this is kind of showing across the different domains. So obviously when you're building an embedded device, not only are there software development involved, you have mechanical, you have electrical, you have electronics involved. So across these domains, what's the sort of viewpoint of Agile adoption and what's the importance of Agile? Not surprisingly, software and systems is representing the group or the field that is mostly interested or mostly looking at Agile as an important way of working. There's definitely pockets of interest across the domains, and that's actually an area where we are working at ElectroCloud currently in terms of researching and trying to better understand how can we help the overall end-to-end product developers, embedded product developers, becoming more efficient, becoming faster, becoming more productive. So we're just about to introduce this concept called multi-domain continuous delivery, which is really all about streamlining and optimizing integrations and release flows across these various domains of software, mechanics, electronics, electrical, and really taking an end-to-end approach to this, from how you're managing requirements all the way to how you're actually releasing and shipping product and how you're actually servicing that product once it's out there in the field. This is us at ElectroCloud working on this, but we are also engaging with a number of partners, including Polaris in this work. So more to come around this. Please let us know if you have an interest, and we'll be happy to talk more to you about this particular concept. So really the next section of this discussion and this webinar is I wanted to present some of the, from my experience, some of the specific considerations or pitfalls that you need to consider and need to think of as you are implementing or as you are thinking of implementing continuous delivery in the context of embedded development. So really 5 different areas, and I'll go through them one by one. As you can see, legacy, speed, infrastructure, compliance, and also the end goal is what I will cover. So let's start with legacy. And to me, this is a very complex challenge. It's problematic, but it's an interesting challenge to take on, and if you succeed, I think your rewards can be fantastic. And really what this is about is how do you manage and how do you take all of your existing IP and all of your existing product architecture, all your existing organization, and how do you take that and adopt that for continuous delivery? So in terms of an architecture, can you actually, is it a modular architecture or is it a monolithic architecture? So when you're building or integrating or testing that system, do you have to take that whole shebang of a product and build it at once, or can you actually break it up into more of a modular way of looking at the product and then test it or validate it or integrate it piece by piece? I think that's a very important aspect of the product architecture. And I realize most systems today are modular, but there are definitely examples out there in the wild where you have monolithic legacy systems that is very cumbersome and very complex to deal with because of its monolithic nature. Organizational-wise, quite a few organizations are divided and sort of siloed in terms of dev, QA, and release, but also within a developer organization, there is very strict separation between sort of the various domains, which also makes it very complex to get this end-to-end streamlined visibility, end-to-end streamlined integration when you need to move towards, again, a state of a constantly shippable product. So organizational-wise, an important and interesting aspect, and I realize it can be complex, especially in a very large organization, but it's definitely something that needs to be taken into consideration as you're moving towards continuous delivery. Testability is really what I wanted to emphasize there was this topic around modular versus monolithic. You really want to make sure that you can test and validate your system at the smallest component level, and then grow your testability from there, such that you add more testing, add more quality assurance as you're integrating more and more pieces of your system. Speed. If you're looking and if you're considering continuous delivery, speed of your end-to-end product lifecycle is of utmost importance. If it takes weeks or months just to get through a change such that it actually is in a state of shipping or release, that will not fly. So you need to look at all of your various bottlenecks of your end-to-end life cycle and pretty much eliminate them. Eliminate all of those bottlenecks, whether or not they are build times, test times, integration times, manual handoffs. Those need to be understood and they need to be eliminated. And obviously there are various approaches on this, and we from ElectroCloud are working on with a large number of these customers to eliminate some of these bottlenecks, in particular around builds and tests, and just breaking those apart and making them go much faster, as well as just managing this end-to-end workflow, just provide that visibility and provide that traceability. But there are lots of aspects that you can add to this concept of slowness in your end-to-end life cycle. So really what you need to start off with is just understand where are your bottlenecks and determine what are my most painful bottlenecks at the moment and start to eliminate them one by one. The third area is really around infrastructure, which is again an interesting topic, a fairly complex topic for a number of reasons. So I'd say out of all of the various software developer, product developer companies that I've worked with over the years, if I would sort of categorize the most compute-intensive developer organizations, definitely embedded developers would end up at the top because of how much computational resources they need just to perform their work. So it starts off with resources just to build the software, resources just to test the software. So they need custom targets, they need some reference boards, they need some simulators, they need some emulators or what have you. Very complex, very expensive, and cumbersome from an infrastructure and resource perspective. And this is something that you as an organization need to have control over. You need to optimize. You need to provide enough infrastructure such that is not a bottleneck as you are looking to improve or make your development environment more productive and more efficient. Lastly, again, it's the actual target management. So managing and getting applicable targets available as you are developing the product and as you are moving the product closer to the state of release. You need to provide appropriate sets of target boards and just managing where the product will actually end up running. And that is, again, a similar challenge, a similar problem, but an interesting one to tackle. And there are solutions, there are approaches out there that is very, very interesting and emerging. I'm thinking specifically around virtualization and simulation and emulation. There's lots of interesting technology that is emerging right now around virtual prototyping in terms of the embedded space. So that is an area I would encourage you to explore further if you feel that you have an infrastructure problem that is blocking you from enabling continuous delivery way of working within your organization. Compliance is obviously a large topic, an interesting area. Personally, I have less of an expertise around this particular topic, but definitely whenever you're dealing with embedded products, and in particular those in the automotive or aerospace and defense industries, obviously there is a lot of regulations, there is a lot of compliance, a lot of certifications that you need to manage. Not only are they complex, and not only are they thorough, they are typically also quite slow. So just to execute and run and make sure that they are accepted. So that is an area, again, you need to understand and you need to take on eliminating the bottlenecks if they are slow, or just making sure that they are automated and repeatable and that such that they don't become a burden or a problem for your individual product developers as they are trying to move their product closer towards release. This is an area I know where Polarion has a lot of expertise. I don't know, Reg, anything you want to add in the context of compliance?
What I would add, David, is the fact that when we talk a little bit later about the potential integration between why you integrate your ALM with your continuous delivery, certainly when it comes to regulatory standards, it is probably beneficial to actually have an ALM integration with your continuous delivery so that the ALM handles a lot of the managing your regulatory documentation and the complete traceability, and then having that integration with something like Electric Cloud's solution certainly will facilitate those particular compliance issues.
Thanks, Brett. Really the last topic of consideration that I wanted to bring up was this notion of the end goal. And again, this is, I mentioned it, I alluded to it earlier, around that you actually, as the typical embedded developer, you don't own or you don't control the final target environment. So getting the actual product out in the hands of the customer presents interesting challenges. And I know, which again makes, for example, this term continuous deployment, being able to ship basically every change out to a customer, it's today not really realistic. But there are certainly organizations and companies that are thinking along the lines of, would that be a possibility? And some of the technology, some of the approaches that is potentially making this happen is OTA kinds of approaches, so over-the-air updating. It is definitely established for smartphones and mobile phones these days, where you get your updates delivered over the air. Certainly not in a continuous deployment manner, but it's on a fairly regular basis. You get these updates in terms of the firmware of the software, and obviously the applications that are on your smartphones. But we're going to see down the line, we're going to see a lot more examples of OTA kinds of approaches in terms of updating the software on your car, updating the software on your TV and such. So I think we're at the beginning of some fairly interesting new technologies and some fairly interesting new approaches in terms of how do I, as an embedded product developer, how do I actually deal with the target environment when I don't control it. So we will see some interesting evolution and some interesting technology being announced here in the not so short, in the near term. So I'm excited about this particular space. So that was a fairly high-level overview of some of the pitfalls and some of the specific considerations that you need to take into account as you are exploring and as you are implementing continuous delivery. Perhaps make it a little bit more related to Electric Cloud and Polaris. So we wanted to sort of present some of the tooling and infrastructure needs that you need to put in place in order to have an efficient and streamlined continuous delivery environment. So I'll just add out these bubbles here. So really at the core of it's this visibility and it's this traceability that you really get from when you're able to manage and orchestrate your pipeline. And with pipeline, we mean basically being able to take any particular work item, any change request, anything that you're actually working on now as a product developer group, and you actually have a visibility or understanding of where that particular work item is in the process. And if you look at that as a pipeline, it basically starts out as a requirement or as a defect or as some kind of change request. And as that work item moves from left to right, it goes through analysis, and it goes through design and implementation and validation and integration and certification, or whatever steps you have in your particular process, to at some point it's being ready for ship, it's being ready for release. And that end-to-end process is really what we think of as the pipeline. So you need an ability and a way to orchestrate that pipeline. So with that, once you have that, obviously you get a fair amount of visibility and traceability. What you also need to think of and consider is to have all of the systems that is involved in the end-to-end pipeline. They need to be integrated. They need to be talking to each other. They need to exchange information or reference each other, such that you have an explicit ability to get visibility across this pipeline. I mentioned the topic around speed and the importance of speed. So really the key to enabling speed at the very high level, at the end-to-end process, I'd say that's automation. So you need to automate as much as possible. Any process that is repeatable in nature, you should look into automating it, whether or not that's a build, whether or not it's a test process, whether or not it's a release or packaging or integration. There are ways to automate those processes, and you better make sure that they are automated in order to enable a very efficient environment such that you can get to continuous delivery. Some of those processes are slow in nature. So whenever, again, to eliminate those point bottlenecks in your end-to-end pipeline, you should look into acceleration technologies and how you can break them apart, how you can eliminate those particular bottlenecks. And again, there are lots of technologies out there to help you do so. Other important aspects, data configuration management. So basically treating every variability in your end-to-end pipeline as something that is configurable, as something that is changing. So you need to control how your data is changing, and you need to be able to have a strict configuration management process around that, such that you have control over your bill of materials, over your all of the various things that is actually changeable and variable. Source and artifact repository, obviously that's pretty much a given these days, that you need a strict way or a defined way of working with source code. So absolutely, that's very important, and it kind of goes into configuration management. Everything is variable, and you need to have control over what goes in and what goes out over these various processes. So really, again, source code management, artifact management. So as your builds and tests and so on is producing results and output, you need to have a way to securely and reliably store and manage that input as well as the output. Tool integrations, infrastructure efficiency. So obviously the pipeline orchestration, no company is the same. No company looks the same in terms of what tools and what infrastructure is being used and being deployed. So your pipeline needs to have the ability to integrate with this wide range of tools and systems, and again, to enable that visibility and to enable that traceability. And I also mentioned, we talked about the importance or the compute intensivity of embedded developers in terms of infrastructure. So again, as you are running your work items, as you're running your development environment through all of these pipelines, you need to make sure that your infrastructure supports and make sure that your infrastructure is being used at an efficient way. The last bullet here, the last bubble is around requirements and test management. It's really at the front end where requirements obviously comes in of the pipeline, and then test management is being used and leveraged across the pipeline. And again, these systems needs to be talking to each other. You need to have an automated way of exchanging or referencing data from each other. And if you can put all of this together, I'm convinced that you have a very good baseline in terms of tooling and in terms of infrastructure that you need to enable continuous delivery. To this particular slide?
Think about it as continuous delivery is managing and executing the workflow and the integration, and then having all those activities, the results of those activities being managed through your ALM, and then having both those work in conjunction. So that's how I would actually think of both the continuous delivery with ALM. But I'll talk about it definitely in more detail on my slides.
Yeah, so this is my last slide. I never really introduced Electric Cloud and what we do. For those of you who've never heard of Electric Cloud, we're really around helping companies deliver software faster. So we're a product company. We really have a continuous delivery platform that is comprised of a few different products that helps you accelerate and automate your builds and your tests and your releases and your deployment. So very briefly, Electric Accelerator is around software build acceleration. So it helps you eliminate that particular point problem of slow and long software builds. And to the right of that, we have continuous delivery platform, which is based upon Electric Commander, and we are just about to announce some interesting applications that is sitting on top of Electric Commander that helps you manage build automation, test orchestration, deployment automation, and then the end-to-end pipeline. So again, a little bit more to come around that down the line in the coming weeks, but it's very much based upon the existence of Electric Commander, which is an enterprise automation platform that is tailored for software delivery. With that, I wanted to hand over to Reg, who will talk a little bit more about Polarion, and then a little bit more about the integration between Polarion and Electric Cloud.
All right, so let's talk a little bit about application lifecycle management. Some of you on this presentation might not. Oh, you see on the right, there's the poll. So I'll give you a few minutes, 5 minutes to actually fill that out. So ALM is really what it is managing the processes and the activities and the results of your full development lifecycle. So meaning that from the inception of source control, creating your requirements, your technical specifications, creating test cases, managing those test cases, executing your tests, whether they're automated tests or whatever kind of tests that you talk about, manual testing, etc. Being able to do builds on that, repeating those processes, and then ultimately deploying that into the commercial world. ALM, as you can see on the different bubbles around the circle, is that provides all those key activities in the development lifecycle and manages that. And ultimately what happens is that you want to have being able to have an audit and full traceability within that lifecycle. So that in a nutshell, very quickly and succinctly, is what Polarion ALM does. So Why should you care? Why continuous delivery and melding together your ALM? Well, from a business perspective, theoretically, with improving your productivity and all the goodies that we talked about, that David talked about specifically, improving the quality with more rapid defect detection, better project visibility, also improving all your different types of tests, ultimately you should have quicker response time and have more stable and actually less defects when you actually release and ultimately, whether it's ship or launch your actual full quality production software. So there is a method to the madness. How does it work? Okay, so how it works is we'll start with development, and this in this particular slide, this is a high-level conceptualization of your typical software development life cycle. By no means is it all-encompassing, but it is definitely your generalized typical life cycle. So on the development side, and this is all in reference to having an integration with your continuous delivery in ALM. In your ALM, you'll create changes to your source control, which will ultimately trigger basically a continuous integration build, and then it'll actually trigger as well the workflow for your deploy process. Second, then once that actually deploy process is reviewed and then someone manually actually changes the status, then that candidate moves into your test environment. And then ultimately it will actually go into production where GA release deployed to production environment. So the end result with this continuous delivery integration with ALM is that you should have full traceability that is actually during your continuous delivery from the creation of your source control all the way to your requirements, to your test cases, and then fixing those test cases and ultimately the builds that go to production. So what I mean by this in more detail, and the highlighted green boxes in this particular slide highlight the integration points between our ALM and Electric Cloud continuous delivery, their workflow solution. So what we have is we start off on the first in the workflow is that we actually have a release candidate. And it's created as a work item if you're familiar with Polaris, and then gets approved, which is the change deployment status. And that second one in the work item when it's actually manually changed to test, so that's that candidate, the work item is moving through its workflow. This is where the actual Electric Cloud continuous delivery actually gets triggered through the ALM. The workflow performs its various deployment functionality. And then what will end up happening is the actual work item, the record, and the documentation all gets updated, and all of the appropriate files that were actually changed are actually recorded and documented for full traceability within the work item and the documents. And it's reflected both in your target and deployed workflow. So we went from development to testing, and then the next sequence of events would be deployment to production. So again, the integration points are highlighted in green, but then we have a GA candidate, and in this particular case is that GA candidate, we call it a work item 1W1, but what will happen is it's very similar to the process that was in the test candidate, whereas once the testing is complete and the release is approved, it actually gets changed manually, so from testing deployed to production in the ALM, and then that will actually invoke your continuous delivery workflow. And then it does all of its performance and deployment. Those tasks get completed, and then ultimately the results, again, get fully recorded in your build record. And then it's ready for ultimately and hopefully for release in full production mode. Benefits, obviously, to that, as I mentioned before, is that the iterations become even more rapid in the agile environment. And then what ends up happening is that hopefully that you have less defects and defects that actually get fixed quicker and earlier, as well as you get a competitive advantage from a business value by getting out to market quicker and bug-free. So next steps here. So we actually will be releasing an integrated plug-in between Polaris ALM actually and Polaris Electric Cloud. What we're looking at now is we request for proof of concept. So if anybody actually wants to get involved and be interested in actually getting a proof of concept, then certainly contact either Polaris or Electric Cloud, and be more than happy to facilitate that with you. Now, what we'll do is we're reaching close to the hour. Any Q&A that we have that came up today, and hopefully we have a few.
I do have one that was sent to me just now. The question is, where can I get access to the plugin?
Good question. So as I said, it's actually in proof of concept currently. We don't actually have a production-ready plugin. Once it will be available from the Polaris extension site, which is where all our extensions are hosted on our Polaris.com site. But what we're currently doing right now is anyone that is interested in getting a proof of concept, then they would need to contact either Polaris or Electric Cloud, and we'll be more than happy to actually help them with it.
Great. The next question that I have is, in the development process, where should we start? With CD? Question mark.
I alluded to it earlier. So I would look into understanding the end-to-end process, pretty much sort of drawing a whiteboard of here are my steps, here are my various things that I actually need to do in terms of shipping product today, and then breaking that up into sort of an understanding of what's going on, why is it taking time, what are my activities, and then look at sort of eliminating or automating or reducing or improving the various pieces, the various steps and the various processes one by one. So again, it's not a silver bullet answer, but enabling or implementing continuous delivery is a long-term, ambitious project. But again, having an end-to-end understanding of my developer lifecycle, of my product development lifecycle, and then attacking each of the processes, each of the bottlenecks, each of the areas that is improvable, just attacking them one by one. That is what I would do.
Great, thanks, David. The next question presented is, does your solution integrate with Jenkins?
Electric Cloud is integrating and embracing Jenkins. So Jenkins is a very good team-based solution for continuous integration. So where we have customers that are using Jenkins in combination with Electric Cloud is where Electric Cloud is managing sort of the end-to-end process, the end-to-end life cycle at an enterprise scale, across domains, across teams, across individual organizations, across geographies. Electric Cloud is an enterprise backbone, and then they are letting Jenkins deal with individual builds and individual continuous integration runs. That's how you should think of the combination of Electric Cloud and Jenkins together.
Polaris ALM as well has a plugin with Jenkins. It's an integration server that we have been integrated with for quite some time.
Good, thanks to the both of you. One more question. Is 100% continuous testing achievable?
I would say that it's certainly a enviable goal and admirable to attempt to get to 100% continuous testing. I compare it to test automation, where if you look at the concept of wanting to achieve 100% test automation in your development process, you'll get to a certain percentage, but it probably will never be 100. So, for example, I take that 70-30 rule. There always will be, at least in the short term to near term, annual testing that's going to have to occur for various reasons, most of them good, so that it will never at this point be 100% achievable, at least in the near term.
Yeah, I had a few comments around that, and I think the answer is a little bit different depending on which domain, depending on which industry you're coming from. Certainly, we know of organizations that have a completely fully automated continuous deployment environment, where basically a developer checks in code and it goes through completely automated all the way into production, and you have these canary ways of deploying. So you're basically rolling out this particular change to a larger and larger and larger target base of your customer, while completely monitoring and understanding if the change is good. So yes, in the context of modern web development, mobile app development, yes, I believe you can get to 100% automated backbone. I'm not so sure about embedded. I'm not so sure about the enterprise product development. There's a lot of complexity. There's lots of legacy. So I would agree with Reg on that.
Okay, another question here, going back a little bit to the integration with Jenkins. How hard is it to migrate from Jenkins to Electric Cloud? And in order to migrate to electric cloud, do we need to start from scratch, or is there an easier way?
It's a very good question. The answer is no, it's not difficult. So a lot of the work that you've done in Jenkins is reusable. Electric Cloud offers a very open and flexible way of defining and configuring your lifecycle. So a lot of the steps or the scripts and so on that you have written to be leveraged and run within Jenkins, they are pretty much transferable into Electric Cloud. And on pretty much on day one of using Electric Cloud, you can take advantage of sort of the enterprise capabilities of Electric Cloud while leveraging your existing investment in terms of the actual scripts and so on. So in general, it's an easy transfer, and I would encourage you to reach out to me or to Electric Cloud if you want more details.
Great, thank you. That pretty much concludes our Q&A. I have a few closing remarks from a housekeeping standpoint. Reg or David, did you want to have any last minute?
No, I definitely just want to thank David for today's presentation. Thank you very much.
Yeah, thank you. It was interesting and very good. So Nancy, do we have a slide with our contact details?
Yes, so just to wrap it up, a good question, David. So what will happen now is that immediately following the close of the webinar, a short evaluation will be sent out to everyone along with all of the contact details and the audio recording of today's presentation. So we hope that you'll share the recording with your colleagues. And again, we will be adding today's webinar to our on-demand library, so that'll be made available in the next couple of days as well. So again, thank you very much to our partner today, Electric Cloud, to David and Reg, and on behalf of Polaris and Electric Cloud, thanks very much for sharing your time with us.
Thank you.
Yeah, thank you. Bye-bye.